How do you find the highest common factor or the greatest common factor? If you're keen to find out, stay tuned. Hey, what's up everyone? Welcome to Ideation HQ, your number one channel in regards to educational learning technologies. Now, we are not only just about educational learning technologies, we've now evolved to sharing math tutorials as well. So, we're not just for educators, we're both for educators and students. In today's tutorial, I'll be sharing with you the concept of highest common factor and how you can determine highest common factor for two or three numbers. So without wasting any more time, let's get started. Before we talk about highest common factor, let's talk about factors first, assuming that I have a number 20. Now, number 20 can be broken down to its factors. And the factors are 1, 2, 4, 5, 10, and 20. So why are these numbers called factors? Because if you take 1 multiplied by 20, you're going to get 20. If you get 2 multiplied by 10, it's going to get 20. You've got 4 multiplied by 5, then your answer is going to be 20. So a few combinations of these factors here, and you multiply them together, is going to give you the number 20. Now, the term highest common factor comes about when you are comparing two or more numbers, and then you will need to determine what is the most or the highest common factor between these numbers. So I've got two numbers, 20 and 35. And now I would like to determine the highest common factor for these two numbers. I'm going to share with you now a strategy or a technique which you can use and apply to determine the highest common factor between two numbers. So first, let's put the two numbers side by side and then draw out this line like this. Next, we need to list down the prime numbers and apply the same steps for prime factorization. If you want to find out more about prime numbers and prime factorization, please watch the video by clicking on the link here. So my prime numbers will be 1, 2, 3, 5, 7, 9, 11, 13, 17, 19, and we may need to go a bit further, but that really depends on the number that we are trying to work out here. So I'm just going to leave it as it is first. And again, this step here of listing the prime numbers is not necessary as long as you know the prime numbers by heart. So let's now start with the second prime number. I've already explained that we're not starting with 1. And we're now going to start off with the second prime number, which is the number 2. Now, we need to now test whether both these numbers can be divided by the number 2. Well, we know that 20 can be divided by 2, however, 35 cannot be divided by 2. Now, this means that we will not be able to use the number 2 for this calculation. We will need now to move on to the next prime number, which is the number 3. So now, we need to test whether 20 and 35 can be divided by the number 3. Well, clearly, both these numbers now are not divisible by the number 3. Which means now I need to move on to the next prime number on the list, which is the number 5. So with the number 5, 20 and 35 are both divisible by 5. So I'm going to put in number 5 here, and I'm now going to work out the division for each of this number with the number 5. So 20 divided by 5 is going to give me 4, and 30 divided by 5 is going to give me 7. Now looking at the number 4 and 7, we now know that these two numbers cannot be divided anymore by any other prime number which is above 5. So this means that number 5 is my highest common factor for the number 20 and 35. So in this case here, highest common factor is equals to the number 5. Let's now go through another example, and this time I have number 20 and number 240, and I'm now going to work out the highest common factor. So let's have those two numbers side by side and then draw a vertical line with a horizontal line. We will now start off with the smallest prime number that can be divided by 20 and 240. So that's going to be the number 2. So let's put the number 2 here on the left side, and now let's divide both these numbers with the number 2. So if I take 20 divided by 2, my answer is going to be 10, and then 240 divided by 2, the answer is going to be 120. At this point now, we are going to test again whether both these numbers now is still divisible by 2. And the answer is yes. So let's do another round of division now with the same prime number. So I'll now take 10 divided by 2. My answer is going to be 5. And 120 divided by 2, my answer is going to be 60. At this point of time, both these numbers are no longer divisible by 2. So I'm going to move on to the next prime number, which is the number 3. Now 3 cannot be divided by 5. However, it can be divided by 60. So in this case here, we will not be able to use 3 because we want both these numbers to be able to be divided by the prime number. So let's move on now to the next prime number, which is the number 5. Now with the number 5, you can see that number 5 can be divided by both 5 and 60. So we can actually use number 5 and then include that here. Let's now move on to another line and then take 5 divided by 5, which the answer is going to be 1. And then 60 divided by 5, my answer is going to be 12. Now at this point of time, there are no other prime numbers that can be further divided by 1 or 12. Now to determine the highest common factor, I will need to put in all the numbers on this side together and bring them across here. So the highest common factor in this case here is 2 multiplied by 2 multiplied by 5, and that's going to give me 20. So in this case here, the highest common factor for 20 and 240 is 20. Sometimes you may be required to work out the highest common factor for 3 numbers. Now, do not be too worried. The steps that you go through when finding the highest common factor between 2, 3, 4, or even 10 numbers, they are all the same. Let me show you how this is done. Now on my screen here, you will see that there are 3 numbers, number 20, number 240, and 400. And the question is to determine the highest common factor between these 3 numbers. So let's work it out the same way. Let's draw my horizontal and vertical line, and let's start off now with the number 2. So you can see all 3 numbers here can be divided by the number 2. So let's put number 2 on the left side, and let's now calculate each of this number divided by the number 2. So in this case here, 20 divided by 2 is going to give me 10, 240 divided by 2 is going to give me 120, and 400 divided by 2 is going to give me 200. Now we're going to test this prime factor again, and we're going to test that with the number 2 again, because all these 3 numbers can be further divided by the number 2. So let's work it out now. In this case here, 10 divided by 2 is 5, 120 divided by 2 is 60, and 200 divided by 2 is 100. Now with this, let's move on to the next prime number, or the prime factor, and that's 3. Well, 3 is only divisible by 60 and not by 5 and 100. So I can't use 3 in this calculation. So moving on, let's now move on to the number 5. Right. So with the number 5, I am now going to work it out this way. And 5 divided by 5 is 5, 60 divided by 5 is 12, and 100 divided by 5 is 20. Right. Now at this point of time, you can see that I can't break this down any further because my first number here has been reduced than the number 1, which means that there's no need to test for any further prime factors here. You will stop at this point. So to determine the highest common factor for these 3 numbers, then the solution is 2 multiplied by 2 multiplied by 5, and my answer is going to be 20. So the highest common factor for 20, 240, and 400 is 20. By now, you should be getting a hang of this, and you should be getting more and more confident in working out the highest common factor. Let's now try one last example. I've got 3 numbers here, 27, 60, and 210, and my task is to find the highest common factor for these 3 numbers. So let's start off with the number 2. Well, 27 cannot be divided by the number 2, so that means that let's move on to the next prime number, which is number 3. Now all these 3 numbers can be divided by 3, so let's put 3 here and create another line. And now let's work out 27 divided by 3, that's 9. 60 divided by 3, that's 20. And 21 divided by 3, that's 70. Now let's now check this line here to see if all these 3 numbers can be further divided by the number 3. Well, the answer is no, because only 9 is divisible by 3. The other 2 numbers are not divisible by 3. And now, looking at this, there are no other prime numbers that can be divided by all the 3 numbers here. That means that my highest common factor for these 3 numbers will be the number 3. So there you have it, guys. That's how you determine the highest common factor. Doesn't matter if it's 2, 3, 4, 5 numbers, the steps to determining the highest common factor is the same. And with this, we've come to the end of today's tutorial. Please click on the like button if you enjoyed and benefited from today's video. And if you would like to receive more news and updates and math tutorial problems on Ideation HQ, please remember to click on the subscribe button. So this is where I'll leave you. I'll see you again next time. Peace out.